to finish out where we were at yesterday, what we have now is I wanted to figure out on these curves to solve it as an inequality algebraically. The difference between what we have today versus yesterday is yesterday we had the full quadratic to an inequality of 0. Whenever you're above or below the curve. Today we're going to set it equal to or inequality to some number. So all you have to do here is factor and solve, and then we're going to put something on a number line to look for where our overlaps occur. Very, very easy to work with. What's your first step to factor this?
Minus the 8.
Minus the 8, good. Now, what I'm going to do here is just kind of leave this as equals 0, because I want you guys to think of it as all we're doing right now is factoring in finding zeros. We're finding boundary points. We'll go back to this whole inequality in a second. What times what's negative 8? You had to go to get 2.
Do you want me to?
I'll get it from you later. I want to get this going first, okay? What is it? I'm sorry?
4.
Okay. So we have x plus 4, x minus 2. Now, if I'm finding my zeros, that means it's giving me zeros at negative 4 and positive 2. You okay with that?
You got it.
Okay. Sir.
All right, so it started off with the equation less than or equal to 8, right?
Right.
And it goes, and you change it just to equal 0.
The reason that I'm doing that is because I want you to think that you're finding a 0. I don't want you to worry about the inequality right now. We'll worry about that when we're done getting the zeros. Then we're going to go back and put it all back together. I want you to see that it's the same process that you're accustomed to. The twist is at the end. So you've got two values, negative 4 and 2. What I want you to do is put them on a number line. Don't make a crazy number line. All I want you to do is place negative 4 and 2. It's still 7. It's still 7. Okay? How many sections do we break that number line into now? 3. There are 3 sets of values. You've got numbers that are smaller than negative 4, numbers between them, and numbers greater than 2. What you're going to do is to figure out where this boundary is going to work with the original inequality, what you're asking about. So what I'm going to do is pick numbers that aren't these, like, I don't know, negative 5, 0, and 5. I'm picking any number that's not my breakpoints. And the reason that I'm doing that is because, remember, anytime you work with inequalities, you never use the values we solved for. So now it's just a matter of substitution to see if it's true or false. The original function, or the original equation, or inequality, was x squared plus 2x. Is it less than or equal to 8? Well, if I check it at negative 5, what's negative 5 squared?
25.
What's 25 plus negative 10?
15.
Is 15 less than or equal to 8? No. So I know it's false. It's false over here. Check it at 0. Is 0 squared plus 2 times 0 smaller than or equal to 8? It's true between. And then try it again with 5. Sir?
Couldn't you just check by using both sides and then it equals 8 and who knows, right?
But you don't know where the boundaries go.
But if they equal 8, then you know if you go to even a little bit more, if they would not equal, it would be more.
But what happens if it did work? The whole idea of throwing the number line there is in case you do have your science book where you're on the outside, so the handlebar side. Okay. It's a testing it once, but you got to test it a couple of times. And notice we're picking really easy numbers. And then test again at 5. Is 5 squared plus 2 times 5 smaller than 8?
No.
So now I know that my shaded area would be between those two values. Looking back at the original inequality, would it include the negative 4 and 2?
Yes.
Why is that? Right. So your answers for this case would be all values of x between -4 and 2. That's where you're getting at. Yeah.
How do you know if it
So are these like all linear then?
No, they're not linear. These are still quadratics. They're still quadratics, but it's just what's happening here is I want you to think about this curve. This curve would look like was x squared. You notice I got my calculator working?
That's nice. Good job. Congrats.
Plus 2x minus 8. I just look at this curve. Where would these what values of x are smaller than or equal to 8? Okay, it's kind of the other way of, instead of being above or below 0, you're looking at where you're at with the 8s. That's all. It's that. You set them up the same way. Is -5 smaller than -4? Is 5 bigger than 2? My answer. Sure. It's pick a zillion if you like.
Wait, how do you know if it was a style?
I usually use 5
We know-
cents. Anything that's really easy to
You
multiply by.
put this sign and this sign. Equal to non plus and
How do you know, how do I know, how do you know
you know,
four
and it's
is
saying
it?
this was his friend.
What do you mean? Like positive 4?
Use that sign.
Okay, if I use positive 4, 4 squared plus 2 times 4 minus 8. Is that smaller than or equal to, oh, sorry. Smaller than or equal to 8. What's 4 squared? What's 16 plus 8? Bigger than 8. What I'm doing here is any number, once you get bigger than 2, would be false, no matter what. If I use 2.1, it won't work. If I use 2.0000004, it won't work. Then that just happens to be, that'll be one of those cases where maybe the sign is flipped, that's all. You will, what's happening here is that these values, the only difference between this one we did yesterday, the only difference between this one, I just want to say this one, and this, oh, I should say, is that this is asking where is it above and below 0. This is looking for some boundary line. That's it. This is a number line style problem. This is above, below on the graph. That's it. Yeah, we can, but there's no reason to. We are, all right, I should rephrase that. We are graphing it, but the way you should do the graph using number one. That's all. This equals 0. This is a number. That's it. That's the only difference. No, guys, it's the same question a lot of people were asking earlier. Seriously. The only difference here is, like we did yesterday, where is this above and below the graph? Number line. That's all. It's all.
So we don't have to like graph it?
No.
Or
When it's,
okay.
you are graphing,
Like
but
on
you're
the
doing,
number
yeah, you're
line.
doing the number
Okay.
line to
I was
figure out your boundary. That's how you're breaking it into 3 parts.
Okay.
Okay, from the zeros. It's either going to be true or false in each one of those.
Oh, right. So how would it look graph? Like just like curiosity.
Does graph look like you would graph? Look like a graph. I mean, it's for what values of x are smaller than or equal, gives you something that's smaller than or equal to 8. Well, all the values of x between, what was it, -4 and 2. No, we're not, there's no shading on this style. Okay, we're not shading that style. You don't shade on this one because it's only one variable. Okay. We're not shading on that one. This one, where is it above or below 0? Well, it's below 0 between this point and this point. Those are the values. That's below 0. Where is it above 0? It's above 0 from here to here. So it's all of these values going here to here. That's it.
So it's close.
How is it really gonna?
It's just a different problem.
So it's just a different way of solving it.
It's a totally different problem.
But you just
You solve the same.
Factor on both sides and it becomes the same problem.
I know, but the way that you show it, because it's showing between a range of value for 8, not above, below 0. It's subtle, but that's all I'm saying. It's just, that's the only difference. One means you're looking between 0, the other one you're using number line. That's all you do, guys. You do the same work the whole way through, but in the end, you use a number line versus looking at a graph. That's it. Yeah,
Actually,
okay. Take a look. If I go through, do that again, which one was it I do earlier?
The others just shot me in the head.
If I look at this one, 2x squared minus 7x plus 3. If I go through that, that is asking me, from what it's written, where is this graph above 0 or including 0? That's what that graph is asking. So in this case, I solve it, and I look for that boundary region. So this is setting us up to factor by grouping, right? What's 2 times 3?
6.
What times what is 6 that you add together to get negative 7? Group it. Get your GCFs. What do I take out of that second grouping? Therefore, you have 2 terms, 2x minus 1 and x minus 3. Gives you zeros at 1/2 and 3. I know that this curve crosses the x-axis at 1/2 and at 3. I also know what direction this is going. I saw that up because A is positive. So if I just plot it real quick, just take a look. Here's 1/2, here's 3. The question was asking us, where is this graph greater than or equal to 0?
So the y doesn't matter.
No, that is the y. It's where it's-
What are
What values of x generate this to be greater than or equal to 0?
Wait, I have
oh wait.
No, that's, no, that's a totally different problem. Here and here.
What?
for that, when you simplify, for the half that you got, you divided 2 by negative 1, right? So would it be, or, I mean,
Add
negative
1
1 by
to-
2.
Add 1 divided by 2.
Oh, okay. Alright.
So as x passes 3, and it becomes larger and larger and larger, this graph gets larger and larger and larger. So what's happening here is as x approaches infinity, f of x is also approaching infinity. You don't have to write that part, but eventually we'll start talking about this in terms of functions, which means it's positive. Okay? It's positive after 3. So as x is greater than or equal to 3, this is getting larger and larger. It's above 0. Okay? Same deal on the other side. It's above 0 when x is less than or equal to 1/2. The curve is above it. That's all that means. Yeah,
So does the midpoint not matter then?
for this one?
Yeah.
No, it doesn't matter at all. In this case here, I'm just putting it on there just so as I'm asking the question, it's easier to see, okay, if I'm at these 2 points, if it's moving upward, that means it's positive, it's bigger than 0, after I get to 3, and after I get to 1/2 going the other direction. That's all that means. Yes, ma'am?
Is that homework,
Yeah, stuff like, it'd be like this, and the other one was like equals 8.
So when it's 0, like graph with the numbers, like the number, like the 8 gives you the 1.
Yeah, that's all it is.
Oh, so
Yeah, for the 15th time, 0, you set it up like this, the other one you use a number line. That's it. You guys, You guys are always looking for the worst case scenario. It's really
They're all the ones together. Add them together.
no,
Wait, so
no. Let's see here. Stop it for listening.
Nobody was whistling.
Oh. Knock it off, Cage.
What does it say on the left? What does it say on the right? Okay, so if it is solved by graphing, that means you're going to kind of do this, find the points, and then figure out if it's above, below the graph with zeros, okay? You still have to factor to get the zeros, right? Okay. So isn't that the exact same as this? Get your zeros, but then go number line? If you think about it, doesn't this, since it's crossing the x-axis, create three boundaries? 1, 2, and 3? Isn't it the same thing?
Yes. That's what I'm saying. It don't matter.
You can graph if you want, but it's, a lot of these are so much easier to factor. They really are. Okay? That's all it is, guys. Don't overthink it. Pretty please? All right. Let me give you a couple of these. I'm trying to remember exactly which one they gave. Third hour. I should have wrote that down. Oh, they already told you? Which means I should give you more.
Marcus.
I see it. I see it.
What do you think we're doing in P12?
Uh-oh. Did I not write it down?
You just looked past them.
That wasn't the prompts I gave him, though. That was...
What do you think we're doing in P12?
Uh-oh.
Probably.
What numbers were they? That was from the other day. What numbers were they?
35 to 41.
Did you realize?
Oh, yeah, that's right, that's right. All right, it's same page. What number again? 31.
My legs are shaking.
No, 35.
35 to 41. Odd.
What page?
44 and 46. 304.
304. Thank you. I thought I had it on there. Oh well. So what I want you to do, page 304, same section. So this is 5.7. 35 to 41 odds. And then 44 and 46. If you hadn't finished up the other graphing parts, we'll go through all that tomorrow. Okay?
Yeah.
Do you want me to cut out the rest of them out of that? Because I can just cut all of that out. Oh, I didn't see JC's head. You're like, well, I guess I could both. I thought it was just Jasmine. I missed it. But But now it's another dual. What's that? You guys can both sign. I honestly didn't recognize it. Well, you're blurry on the other one.
What is up with this?
Powder puff. I'm the quarterback. I can't miss that.
I'll put a wig on and I'll be the quarterback.
Okay. We're the same height and everything.
Yeah, yeah. Our mannerisms are the same too. I'm sure we run just the same. Oh, it's actually white. I used to.
What?
I changed
Can
the color.
Make it purple?
Sure.
How do I do this?
Leave it on.